All right, so let's take the fifth law. In the previous video, I explained the first four laws. The law where you get to add the powers, where you get to subtract the powers. We talked about the negative, the zero index. And today we'll be dealing with negative index, fractional index, and fractional index. And then in the next video, I will be explaining exponential equations in detail. So let's get right into it. We have the fifth law, which is the negative index. And what the negative index tells you is that if I have x to the power of negative a, we could rewrite this as 1 to the power of x raised to the power of a. No, sorry, 1 over x raised to the power of a. So that means you take out the negative part here and what? Turn it into a fraction. That's basically it. So what this means, this can also be vice versa. It means you can go from this to this. So let's have an example. Let's say we have 3 raised to the power of 3 divided by 3 raised to the power of 5. Of course, it's going to give you 3 to the power of 3 minus 5. And this is going to give you 3 raised to the power of minus 2. Notice that this is a negative index, and we can rewrite that as 1 over 3 raised to the power of 2. And this is the same as 1 over 9. Of course, if you do go the long route, you can have it as 3 raised to the power 3 divided by 3 raised to the power 5. That's the same as 3 multiplied by 3 multiplied by 3 divided by 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. And then you have this cuts this out, this cuts this out, this cuts this out. And notice that you have this as 1 over 3 multiplied by 3, which is basically the same as this. This is the same as 1 over 9. So this works perfectly. Whichever one you choose to work with, yeah, okay. So you can have two laws playing all at once. Let's have another example too. Let's say I have 3 x raised to the power minus 2 y raised to the power 3 multiplied by 4 x raised to the power of 3 y raised to the power of 1. This is the same as 3 multiplied by 1 over x squared. Did you notice that? Then multiplied by y raised to the power 3. Then multiplied by 4 x cubed y raised to the power 1. Notice here that I can write this as 3 y cubed over x squared multiplied by 4 x cubed y. Notice here now that I can have, let's multiply the ones that look alike. So we can have 3 times 4, they are both constants. So 3 times 4 is going to give you 12. We can have y raised to the power 3 plus 1, because this is y raised to the power 3 times y raised to the power 1. Then we can have x raised to the power of 3 minus 2, because this is now division. So we have 12 y raised to the power of 4 x raised to the power of 1. And that's the same as 12x y raised to the power of 4. Did you notice how simple that was? Let's take one more example and we move to the next law. One more example, example 3. Let's have x to the power of 5 y to the power of minus 3 raised to the power of 2 here divided by x to the power of 7 y to the power of minus 6. What did you notice here? We can have this written as, now notice that we have a power and we have a power outside here and another power inside here. So we spread them across. So let me write that x to the power of 5 y to the power of minus 3. So we spread the powers across. So that's going to give you x raised to the power of 5 multiplied by 2, then y raised to the power of minus 3 times 2 divided by x raised to the power 7 y raised to the power minus 6. Notice here that we have x raised to the power 7, x raised to the power 10 now, x raised to the power 10 y raised to the power minus 6 divided by x raised to the power 7 y raised to the power minus 6. Now this is division. Let's pick the ones that have the same base. So x raised to the power 10 divided by x raised to the power 7. So this and this. This is going to give you x raised to the power 10 minus 7 because it's division. And then let's go for the y part. That's going to give you minus 6 minus 6. That's going to give you x raised to the power of 3 y raised to the power of minus 6 plus 6. And this is going to give you x raised to the power of 3 minus 6 plus 6 is 0. So y raised to the power of 0. This is, recall that anything raised to the power of 0 is 1. So this is x raised to the power of 3 multiplied by 1. And this is the same as x raised to the power of 3. That's basically the negative index law. Let's go to the fractional index. That's the sixth law, fractional index. The fractional index tells you that if I have x raised to the power of a over b, I would take my b as a root of x and my a as a power. In essence, I'm saying if I have 2 raised to the power of, or let's use 4 raised to the power of 3 over 2. I'm saying I'm taking 2 as the root, which is now square root of 4. Then 3 as a power, raised to the power of 3. That would be equal to square root of 4 is 2, then raised to the power of 3. That's going to give you 8. We can also have an example 2. We can also have 2 raised to the power of 1 over 2. And this is going to give you just the square root of 2. We can have 3 raised to the power of 1 over 3. This is going to give you the cube root of 3. Notice that 3 here, in this case, circled here, is going to be a root. So I'm using it as cube root. The same thing applies for 4, 1 over 4. So if I have 16 raised to the power of 1 over 4, I'm saying the fourth root of 16. And that's going to give you 2. So that's basically how to work around it. So let's take a nice example. Let's have 81 raised to the power of 2 over 4. 2 over 4 divided by 27 raised to the power of 1 over 3. This is going to give you the fourth root of 81 raised to the power of 2 divided by the cube root of 27. Okay, let's say raised to the power of 1. So if you have not been following, somebody might be asking, where did this 1 go? I've used it as a power, and anything raised to the power of 1 still falls as the same thing. So this is the fourth root of 81 is 3, then raised to the power of 2 divided by the cube root of 27 is also 3 raised to the power of 1. Notice here that I can say this is 3 raised to the power of 2 minus 1, and this is 3 raised to the power of 1, which is basically the same thing as 3. So that's basically that. Let's take one more example and we end this video. So in the next video, I'm going to be explaining the exponential equations. Let's have example 3. This is the same thing as spreading the powers. Notice here that even though this is a fractional index, there's another law at work. So before you write this as the cube root of 3, the cube root of x, sorry, apply that law. So that means I'm saying x raised to the power of 1 over 3 multiplied by 3, then y raised to the power 3, then multiplied by, y raised to the power 3 times 3 multiplied by x raised to the power 3, y raised to the power 2, z raised to the power minus 2. This is going to give you x raised to the power 1 because 3 cancels 3 here. Then y raised to the power 9 multiplied by x raised to the power 3, y raised to the power 2, z raised to the power minus 2. This is the same as x raised to the power 1 plus 3, y raised to the power 9 plus 2, then z raised to the power minus 2. And I can write this as x raised to the power 4, y raised to the power 11 divided by z raised to the power 2. Why is that? Because this is a negative index, so it has to become a fraction. So if you don't understand what I did here, you have to go back to the previous video where I explained negative index. So in the next video, like I said, I'm going to be explaining exponential equations. I'll be showing you how to solve various forms of exponential equations. And I'll also drop a list of 20 questions for you to try your hands on. Don't forget to like, subscribe, share with your friends, and also follow my pages across all social media platforms, especially on TikTok. I'm on TikTok at Mathlete. And share this YouTube page with your friends. Thank you.